Okay, cool. All right, so we're going to talk about chapter 3, systems of equations. Inequalities, I don't think I'm going to do with you guys. Matrices, I'm not going to do. Just going to focus on systems of equations in these set of notes. So this is a little cheat sheet on how to graph in the calculator. We'll come back to that in just a little bit. And this type of equation, an absolute equation, I haven't talked about that yet with you guys. I'm going to see if I can maybe sneak that in sometime this week. Another thing too about this week. So on Thursday, we're gonna just do an overall review of everything, and maybe go back and look at some challenge problems. We didn't do that, and then we'll do an Algebra 2 readiness exam on that Friday. The Algebra 2 readiness exam it's a multiple choice exam I located, 58 questions, and the thing is that you don't have to stay the whole 2 hours on Friday. So if you get this done within like an hour, you're free to go. So Friday would be a short day anyway. For those who are not going to be here, I think a couple of you guys are not going to be here Friday. You could probably do some review on Thursday if you want, and then do the assessment after that. Or just do assessment right when class starts. You could do that too. And again, I'll still want to see your results, but I'll let you keep it, and that's just for you to to learn from. And I'll try to give some feedback by email, like, hey, here's blah blah blah, what you should work on, and whatever. So and once we get past Wednesday, it's kind of smooth sailing after that. And Friday will be a short day too. So if you may want to let your parents know, you might be done a little earlier, or if you have another thing to get to, you can do that too. So, all right. So let's move on to page 2 first, and I'll come back to page 1 in a little bit of how to graph in the calculator. So let's look at this one here. So the solution of an equation is a value that makes the equation true. We know that, right? Now, a system is 2 or more equations. So we're going to deal with systems today. And the solution to a system, which I did put in the video, the solution to a system of 2 linear equations is the point of intersection. Unless the lines don't touch, or the lines are identical. When they're identical, we say there's infinitely many solutions. When they don't touch, we say there's no solution. So those are the 3 scenarios. Most of the time, they touch just once. But sometimes they may not touch. That means they're parallel, so no solution, or they're the same line, so they cross everywhere, right? They overlap. They overlap. It's infinitely many solutions because all these points that could work. Not any point, not any value would work, but just there's a whole bunch of points that work. And a line has an infinite amount of points, right? So there you go. Okay, so let's move on to this problem here. I'm going to do this by hand first. And you'll see why doing this by hand is probably not the best approach. We'll do it by hand, and then we're going to do it in the graphic calculator. And I'm trying to think what the answer was for this one. I think it was -2. Or is it 2? It was 2. Yeah, I think it's 2. No, it was -2. Okay. But anyway, let's just graph it. So -2 is your y-intercept, and your slope is 3. Okay. And let me get a line. Let me adjust this. Okay. So notice how I have a very straight line. I mean, if I did freehand, I probably would, especially with a mouse, probably a little hard. And so, you want to be kind of accurate, especially if you have a ruler that could help. So next one, let's change colors. Let's go green. let's see here, positive 2, up 5 over 1. Think that makes sense? Yeah. Okay. I need to expand this. Oh, come on. Then make an adjustment. Okay, it's kind of hard to tell. This is why this is not the best technique. It's kind of hard to tell, but where do you guys think it's touching? If you had to guess. Probably somewhere over here, roughly, right? I mean, I know the answer, I just looked at it, but looks like -2, -8 is roughly where they touch. Not terribly accurate, especially when both slopes are positive and pretty close together. If you have one positive and negative slope, it's more obvious because they're kind of going opposite directions. But it looks like the solution will be -2, -8. And I could, test it by plugging -2 into each equation and get -8 in each case for y. So yeah, there you go. That's what happens. I'm gonna try to do this in the calculator. Actually, let's do in the calculator right now. So if you want to follow along, great. If it's being recorded, so that's fine too. So very simple. Turn on the calculator, go to y equals, if anything's there, clear it. Type in the equations. So 3x minus 2 and 5x plus 2. Graph. And then find where they touch. If you hit second trace, option 5, and just hit enter 3 times. 1, 2, 3. There you go. I'll walk you through it again. Turn on the calculator, or you hit clear. Go to y equals, punch in the equations. If your window's messed up, go zoom and pick option 6. It resets the window from -10 to 10 for x and -10 to 10 for y, and does a tick marks by scale of 1. So if you hit window, you see it kind of resets the window in a way, so it's kind of a nice window to work with. And then to see where they touch, hit second trace. That's a calc menu, the calculate menu. Sorry, second trace. Pick option 5. And why do you hit enter 3 times? What you're doing is notice the cursor's on the first line, and the upper left corner says y1 equals 3x minus 2. You can move the cursor close to the point of intersection or away, it doesn't really matter. Sometimes you're not dealing with lines. Sometimes you're dealing with parabolas. Remember graphing parabolas or like really wavy curves. Sometimes your graphs might touch more than once, like 2 or 3 times or 4 or 5 times. So then you have to move the cursor close to the point of intersection so the calculator knows what to look for because it looks for the closest one. That's why I ask a question, the first curve. But because I know these touch once, I just hit enter and it's fine. Second curve, hit enter, it's fine. And as for a guess, like what you think the point of intersection is, just hit enter, it's fine. And it gives it to you. Desmos, I think, is a little more user-friendly. Y equals 3x minus 2. You'll see why when we do the next example. Y equals 5x plus 2. Zoom out. And just mouse over to where they touch. And there you go. Done. So easy peasy. Yeah, not that hard, right? Okay, now let's talk about this next one here. Now, this is not written in slope-intercept form. It's okay. We'll put in slope-intercept form, or you could graph the intercepts. Kind of up to you. If you graph it by using intercepts, oh geez, what am I doing? Hold on. Here we go. I know 2 comma 0 is on the graph, and 0 comma 8. I just plug in 0, 0 for x and y. And let's connect them again. Maybe good about this. I'm not gonna try to freehand it. Heck, there we go. Looks pretty good to me. Next up, you'll have half comma 0 and 0 comma 1. That's kind of hard to do. I don't know why I did that. And gosh, it's kind of hard to tell. I don't really like this technique. I think. What do you guys think? I don't know. What do you guys think of touching? Like 3.5, comma -6, I think. I clearly didn't do this very well. Sheesh. Yeah, I really didn't do this very well. You can see why this is not a good technique. This is actually a crappy technique. I'm pretty sure the answer is 3.5 comma -6. We'll go to Desmos. That's a little better in the graphic calculator. I think that's going to be the answer. Now, here's the problem with the graphic calculator. You have to get y by itself. I know you guys can get y by itself. Let's actually go to Desmos. Desmos is kind of cool because you can actually just type in the equation like it looks. So 4x plus y equals 8. And then 2x plus y equals 1. Yeah, I was right. 3.5 comma -6. So you can see it's not the best technique. I would not suggest you do it graphically. It's good to know what happens graphically. I'll not suggest it because it's just to do it by hand is just not terribly accurate. So what should we do? We should approach this algebraically. That's gonna be a better way. I mean, yes, you can use a graphic calculator or Desmos, that will be accurate, but by hand graphing, I wouldn't recommend it. So there's two techniques. You might remember these two. I think we tried to reinforce it in geometry, and we'll see this again in algebra 2. Substitution is usually going to be the more reliable technique because you can do it for nonlinear equations also, like parabolas or other weird graphs. But elimination is good too, depending on the situation. Like in this case, I'm going to do elimination. Because what if I just add the equations together? Why would I add the equations together? Yeah, the y's would cancel exactly. You get 6x equals -3. X equals -½ Then you could solve for y. Add half to both sides. And y equals 1/4. Kind of a weird situation with the fractions, but it is what it is. I think that's it. Yeah, that should work. Not too hard. Seems fine, right? Does that make sense? And if the opportunity presents itself where the variables cancel out very nicely by adding or even subtracting them, if it was like 5x plus 2y and x plus 2y, so the 2y's cancel by subtraction, you do that too. Or you can multiply one of the equations by -1 and add the equations, whatever you want to do. Now for this one, substitution would be the way to go. That's exactly what it means. You replace one of the letters with that expression in the other equation. Now you got one variable, it's easy, right? And why do we spend all this time solving linear equations? Because now it has to be second nature, right? You know, we spent all this time solving equations with single variables last week, and you guys did it so long in algebra 1 and geometry and pre-algebra. Should be fine at that. But once you substitute, it's smooth sailing, right? And then solve for x. You can see why graphing would be hard to see those fractions. Just replace. I'm going to change the 1 to 3/3 because that is what 1 is, right? It's 3/3. You should get negative 13/3, I think. Is that good? Yeah, okay. All right. Should we do this? I think we'll do this one Desmos because I haven't really had this discussion of how to graph absolute value with you guys, and I don't want to rush that. Then we could do a discussion of 6 and then some word problems after that. This one, let's use Desmos. Actually, what I want to do first is investigate this. You may have talked about it in the video. Okay, so what's happening with absolute value of x? It's a V shape. And each portion is straight, right? That's straight, that's straight. Why is it a V shape? What's absolute -2, guys? If I point -2, what comes out? Absolute -2 is 2, right? How about -4? 4, -10, 10. So all the y values are positive. Instead of being down here in the third quadrant, go up in the second quadrant. So it's like, basically it's like graphing y equals x, right? Where you take this portion and you flip it over the x-axis. Whereas the right side stays where it is because everything should be positive. In essence, an absolute value, if you think about it, is a piecewise function, right? It looks like two pieces. Y equals x when x is bigger than or equal to 0. Negative x when x is less than 0. And the equal sign could go to either one, doesn't really matter. That's what you're doing. You're graphing two different lines, but just portions of each. So it's like a V shape. Now, what if I put a +1? What just happened? It went up 1, 2, 3, 4. As it should, because you're changing what y was originally. Originally, y was 0 at x equals 0. Now it's going to be 1, 2, 3, or 4. Or -1, -2. Oh, -2, -3, -4, and so forth. If you put something on the inside, it goes right. Because now to adjust, x has to be 1 higher to get y equals 0, or 2, or 3, or 4. Or 1, 2, 3, 4. There you go. It gets more steep, or it could flip, or it get wider. So a bunch of possibilities that could happen. In our case, we have absolute of x -3, I think. Negative x plus 3, never mind. Negative x plus 3. Let's put a negative out in front. Plus 3. And what was the one? 2x minus 5. Jeez. Y equals. Cool. And that's where you touch. You only touch once, as the graph shows us. And that's 8/3, I think. Comma 1/3. Which actually makes both of them happy if you plug it into either equation. You should get the same result. Now, how come we don't get two answers? See, if I were to, now don't do this algebraically, I'm just going to do it for you guys so you see it. But if I were to approach this algebraically, absolute negative x plus 3 equals 2x minus 5. So I'll move the 3 over and multiply by -1. So x equals that, or negative x equals that. So here x equals 8. Here 3x equals 8, x equals 8/3. But notice that can't happen. If I plug in 8, I get -5 here. And I get 11 here. I get different things. So it doesn't happen. So that's why the graphical answer has to agree with the algebraic answer. Algebraically, we got two answers. But I throw the 8 back in, numerical doesn't work. And graphically, we don't see that happening either. So graph is kind of good to have still, just to verify your algebraic solution. So again, why do we do both? To validate each other. You want the graphical solution to validate the algebraic and vice versa. So you want an agreement. So the more ways you do it, you get more validation. So that's what's happening with that one. For 6, discuss the problem, we'll just talk about it here. Will two linear functions always have an intersection? The answer is no. Why not? It could be parallel. Or the same line. And they overlap. That could happen. Will system linear could always have a solution? No. Again, because it could be parallel. How many 6 linear function and absolute function have? They could have none, 1, or 2. So let's say I do maps out like this. And they could completely miss each other. Or it could be kind of like this. Or it could be like this. Those are the 3 ways it could happen. And you would see it algebraically if you solved and tested the answers, you could get no solution. Or if you get 2 answers, one of them works, one doesn't, or both answers work. Okay, questions on that? We good? Okay. I think now we get into word problems. Okay, so a Caltrain monthly pass costs $40.40. A one-way ticket costs on the clear cards $1.60. Should you get a monthly pass or pay as you go? It's a little tricky. I say let X equal the number of trips. So this one's just gonna be Y equals 42.4. That's because it's just flat for the whole month. This one's gonna be Y equals 1.6x. So if I approach it graphically, so ultimately they're gonna meet somewhere, right? If I solve it, and let me get a calculator. Yeah, 26.5 is where they touch. You can't go on 26.5 trips, but if you go on 26 trips, the Clipper card is still better, or the monthly pass is still better. But once you go 27, sorry, I take it back. If you go 26 trips, just get the Clipper card and do one way. Do the monthly pass if you do 27 or more trips. Then it's worth it to get the monthly pass. So it's just trying to figure out what's the best scenario, depending on how many times you write it. 27 or more would you want to go monthly pass. Okay. Um, hold on. Oh, I see. Okay. Okay, I see what's going on here. This is kind of fun. I'm not sure. Does anyone like look at the stock market or play the stock market? No. Okay. From what I don't really play, I just kind of my money in my retirement plan, just let it just look at it every month or two or see how it's looking. But apparently the stock market's getting pummeled from what I read in the New York Times, or at least the Japanese market's getting pummeled. Let's go to Google. Well, I'm ready at Google. Duh. Let's look at anyone want to look up a company? They're curious what it's worth. Just any big company. Apple. I thought Apple too. Okay, Apple. Right. 211.4. So a year ago, so today's what? We'll go August 7th. So it's 178.85. Well, that pair's done well. And then now it's worth 211.04. That's what it's worth right now at this moment. So 211.04. That's pretty good. Obviously, you invest in Apple back in the 80s, you are doing very, very well. It's actually, you guys know the founder, sorry, the name of this building? He was like Steve Jobs' mentor, Bill Campbell. Yeah, he was like, yeah. So kind of, yeah, he obviously did very well for himself. Anyway, another company. Think of that one you guys want to look up. What was that? Zoom? We could do Zoom. Zoom's not doing so hot. Zoom stock. Here we go. 1 year. Yeah, it was high. Actually, if you look at 5 years, it was really high when the pandemic was starting, right? Oh crap. It was like worth a lot of money. Look at that. So 68.66. And now 56.34. So Apple kind of makes sense because everyone's using their iPhones. People are spending money on um, Apple TV or whatever. So percent change. Percent change. It's actually good we talk about this. It's new minus old divided by old. And times 100%. Actually, let me rewrite that. Okay. So for Google, how's Google been doing? So Apple, my bad. Google called Alphabet. I should know that. Facebook's Meta, so forth. So you want to know how it changes from the old price? Let's see here, 211.04 minus 178.85 divided by 178.85. Should be about 8. Oh, it actually comes pretty close. It's about 18%. And then let's see the next one here. 56.34 over 56.34. Sorry, 60.66. Always divide by the old. Oh, interesting. It's negative 17.9%. It's kind of going the opposite direction. Okay, so it clearly lost money on one, but made money on the other. But let's say you put more money in Apple and Zoom. Let's say overall you made 4% interest. I just made that up. How much do you invest in each stock? Okay, let me get rid of the stuff I don't need right now. Okay, so how much do you invest in each stock? So here's what you want to do. Let X equal the amount of money spent on Apple. Let Y equal okay, how much money do you spend total on your investments? So X plus Y equals 10,000. This is the tricky part. Actually, let me move this down here. Okay, the percentage. You yielded 4%. So it means you made some money, right? What you do is you put the percentages next to each of these. 0.18x minus 0.179y because it's negative, or 0.174y, sorry, equals 0.04 times 10,000. Because you made some money. Actually, you made 400 bucks, I think. Okay, we're good. How do you solve it? You can do substitution, elimination. It's kind of up to you. I'm just gonna go to Desmos and just cheat. So it's a step I care more about than anything else. So X plus Y equals 10,000. 0.18x. 0.18x. My goodness. 0.18x minus 0.174y equals 400. And that's the beauty about Desmos, because you have to adjust the window in the calculator that makes it hard. Okay. So it seems like not a nice whole number, but it's okay. So roughly $6,045.20 in Apple and $3,954.80 in Zoom. So you spent more money in Apple as you should, because you made some profit because I chose 4% interest as a return. So that's just a system of equations we just solved. So we had to set up the equation first, and then we use Desmos to solve it. It's totally fine. But the ones that are more algebraic, I want you to do it by hand. So we're okay with that? All right. Okay, let's do a couple more here, and then we'll take a break. To raise money for a new football team, Figheart Prep sells silk screen t-shirts. Short sleeve t-shirts cost that much and sold for that much. Long sleeve cost that much and sold that much. The school spent that much on the t-shirts and sold them for 4,200. That's real easy. Let the short sleeve be X. Let the long sleeve be Y. 5X plus 7Y equals 2,500. 8X plus 12Y equals 4,200. And we're just going to graph it and see where they touch. Right? Because again, the cost is 2,500. So you have to use the cost values for X and Y. And what you made or sold it for is 4,200, and you got to use the sales price for that. There we go. That's the answer, 150 and 250. So you still 150 short sleeve, 250 long sleeve. Done and done. Right? There we go. Pretty simple. Just have to determine what X and Y, I mean, not determine, just choose what we want X and Y to be and set it up correctly. Okay, lastly, number 4. 76 tennis players at a tournament, 26 games were in progress at one time when all 76 players are playing either a single or double game. Double game requires 4 players, single requires 2. How many each kind were in progress at one time if all 76 girls were playing? So X will be the number of single games. Y will be the number of double games. The 26 games being played. Easy peasy. And 2x plus 4y. This is the part that's not as obvious. Because think about it, X is the number of single games. Y is the number of double games. There are total 26 matches happening, right? So that's why X plus Y is 26. But how many people are in a single games match? 2. How many people are in a doubles match? 4. How many people are involved in matches? 76. So that's what you have to do is you have to translate it correctly. So it's one way you could think of it. If it helps, X equals the number of single game matches. Y equals the number of double game matches. And then this equation right here, number of single game matches, you don't have to write this down, plus the number of double game matches equals the total number of games. So you just do a model and you get the answer, right? Or here, the number of people playing singles plus number of people playing doubles equals the total number of people, right? That's not so bad. Boom, done. You're good. Yeah. Okay, cool. All right, it's not perfect time, 9:55. Let's come back at 10:10. We'll come back and I'll see if I can find a game for us to play or do some problems, something like that. So that's it.